Hi, my name is Ganre. I am a former A-level student and I graduated high school with straight A stars, and I'm here to help you do the same, or if not, just to make A-level maths a little less challenging for you. So in this video, we'll be looking at hidden quadratics, and the syllabus point will focus on states that we should be able to recognize and solve equations in X which are quadratic in some function of X. So any equation that is quadratic in some function of X is known as a hidden quadratic. To be able to define what a hidden quadratic is, we have to first define what a quadratic equation is. A quadratic equation is any equation that can be written in the form ax squared plus bx plus c is equal to 0. So hidden quadratics do not initially appear to satisfy this form, but with a little bit of work and simplification, you will notice that they do actually satisfy this form. So to learn about hidden quadratics, we're going to look at examples of hidden quadratics and we'll walk through them and explain them together. So number 1, solve the equation x to the power 4 minus 5x squared plus 4 is equal to 0. So as it appears here, it doesn't look like it's in the form ax squared plus bx plus c is equal to 0. But we can change it so that it looks exactly like this form. So to do that, we're going to rewrite x to the power 4 as x squared in brackets to the power 2. Using laws of indices, if you simplify this should give you x to the power 4. So once we have done that, we are going to say let y equal x squared, and wherever there's an x squared, substitute with y. So it becomes y squared minus 5y plus 4 equals 0. And as you can see, this satisfies the form ax squared plus bx plus c is equal to 0. Once we have this form, we can solve the quadratic equation, and in this case we have used factorization, and the roots that we get are y equals 4 and y equals 1. But remember that our original equation was in terms of x, so we have to get back to x squared. So we'll use the statement that we created earlier, which is let y equals x squared. So since we have the values for y, we need to get the values for x. So to do that, we're using y is equal to x squared. So at y equals 4, substitute y with 4. So it becomes 4 is equal to x squared. Take the square root of both sides, you get x is equal to plus or minus 2. We do the same when y is 1. Substitute y with 1, it becomes 1 equals x squared. Take the square root of both sides and x is equal to plus or minus 1. So your final answer will be x is equal to plus or minus 1, or x is equal to plus or minus 2. Now let's move on to the second example. Solve the equation 6x plus root x minus 1 is equal to 0. So first let's start by changing root x to x to the power half using laws of indices. So this would become 6x plus x to the power half minus 1 is equal to 0. And again, we're going to rewrite x in terms of x to the power half. So it becomes x to the power half in brackets squared. And if you multiply this out, it will simplify to give you x. So this is 6x to the power half squared plus x to the power half minus 1 is equal to 0. Now we can create the statement let y equals x to the power half, and wherever there's an x to the power half, you're going to replace with y. So it becomes 6y squared plus y minus 1 is equal to 0, and this is in the form ax squared plus bx plus c equals 0. So it is a quadratic equation, and we will factorize it and get our roots. So in this case, after factorizing, the roots are y equals 1 over 3 and y equals negative 1 over 2. And again, we want our answer in terms of x. So we'll go back to the statement that we created earlier. Let y equals x to the power half. Since we have the y values, we can now get the x values using this statement. So let's evaluate at y equals 1/3. So substitute y with 1/3 and square both sides to get rid of the power half, and it becomes x is equal to 1/9. Now let's evaluate when y is negative half. So we use the same statement, y equals x to the power half. Substitute y with negative half. And now remember that x to the power half is the same as the square root of x. And whenever you take the square root of any number, the resulting answer is always positive. So for this reason, since we have the equation negative half is equals to the square root of x, it means that x has no solutions, because when you take the square root of any number, you cannot get a negative result. Therefore, here you leave it as x equals no solutions. And so our final answer should be x is equal to 1/9. Now let's look at the third example. Solve the equation tan squared x equals 1 plus tan x. For this example, I'd advise that you do trig first, then you come back to this example, but it follows the same principles as the other two examples that we have covered. So let's start by putting all the terms on one side. So it becomes tan squared x minus tan x minus 1 is equal to 0. So again, we want to write it in the form ax squared plus bx plus c is equal to 0. So we can do that by saying tan x squared minus tan x minus 1 equals 0. Then we're going to create our statement, let y equals tan x. Wherever there's a tan x, replace it with y, so it becomes y squared minus y minus 1 equals 0, which is a quadratic equation. We solve our quadratic equation. In this case, this quadratic cannot be factorized by sides, so we use the quadratic formula, and we get our answer here as x is equal to 1 plus or minus root 5/2. Then from here we go back to the statement we created earlier, let y equals tan x. And since we have the y values, we substitute the y values with the answers that we got. So we start when y equals 1 plus root 5/2. So equate that to tan x. And then here you solve for x and you get x is equal to 1.02. We do the same for when y is 1 minus root 5/2. Substitute y with 1 minus root 5/2 and equate it to tan x. So for x, and you get x is equal to negative 0.554. And that is your final answer. So that's all for today's video. Thank you for watching. I'll leave a link down below in the description to access this PDF. And if you want more resources, you can click the link below to my website.